Chapter 2, Lesson 7, Percent of Change. The percent of change is just the ratio of the change in an amount to the original number. So we're just comparing how much it changes to what it originally was. And we express the percent of change as a percent. It's called the percent of change. If the new number, so we're going to look at a number, it's going to change. If the new number is bigger than the original number, it is a percent of increase. All right, it goes up, it's going to be positive. If the new number is smaller than the original number, it is a percent of decrease. So it's going to be going down, and it's going to leave us with a negative number. The change will be negative, and the percent will be negative. Two equations we can use. The first one is basically you're using the percent proportion. So you take the change, and how we find how much something changed is we take the final amount, or sometimes we call it the new amount, and we subtract the original amount. So what did it start at? That's the original amount. And we subtract that from the new amount, the amount that it finished. So we find the change, we put it over the original amount, and then we put the percent out of 100, and we solve the proportion. Or we can also use another one that's very similar. You take the final minus the original, same as in the other equation. That's going to give you the amount of change. We're going to put that over the original amount, and that's going to equal a number that we're going to make a percent by changing it to a decimal. So it's important you remember if you use that method to change it to a decimal. Let's look at an example. So yesterday there were 20 people in class, today there's 23. What's the percent of change from yesterday to today, and was this a percent of increase or decrease? So I would actually answer the second question first. So yesterday there were 20, so that was the original amount. And then today there are 23, so this amount is the new amount, or the final amount. So was this a percent of increase or decrease? Well, the number went up, so it's going to be a percent of increase, which also helps us to know that my answer should be positive. The change should be positive, and the amount of percent should be a positive number. So my change, so I'm going to take, okay, so the final amount was 23. I'm going to subtract the original amount. I'm going to put that over the original amount, and that's going to equal some percent, which I don't know, out of 100. So now I'm going to simplify and solve this proportion. So I have 3 over 20 equals p over 100. I do my cross products. 20p equals 300. Divide by 20, and p equals 15%. Right? If the original or new amount is what's missing, if that's the unknown, we know the percent, but we don't know one of the original or the new amounts, use the same formula, and you just plug it in and solve. Let's look at an example of that. So the total number of passengers on the cruise ships increased from 10% in 2007 to 2009. If there were 17.22 million passengers in 2009, how many were there in 2007? So 2007 is my original amount, so that's what I don't know, and 2009 is my new amount, and this is how many were in 2009. So this is the new, or the final, and this is my percentage. So I'm going to say, okay, to find the change, I take the new amount, I subtract the original, which I don't know, so I'm going to call that x. I put it over the original amount, which I don't know, and that's going to equal 10 over 100. Now I'm going to cross multiply, so I'm going to say, okay, this gives me 10x, and over here I have to remember to distribute, and so I get 1722 minus 100x. And I combine the x's, so I'm going to move this 100x over to the other side by adding 100x, adding 100x. So I have 110x equals 1722. I divide both sides by 110. And on my calculator, I'm just going to round to the nearest hundredth. I get 15.65 million passengers. And that's an estimate because I did round on my calculator, so I can put approximately equal to. Percents of change are commonly used to find sales tax and discounts. All right, we don't need to use the whole formula though. We just need to find the percent of a number. And how we do that is by multiplying the number by the percent. And when we multiply it by the percent, make sure that we change the percent to a decimal. Okay, so sales tax is what we're going to do is we are going to take the original price. We are going to add the tax, and that gives us the final price. And the tax is where we multiply the number by the percent. And the discount, we're going to take the original price, and we're going to subtract the discount, and that's going to give us the final price. Okay, so Marnie's purchasing wire and beads to make jewelry. Her merchandise is $28.62 before tax. If the tax is 7.25% of the total sales, what's her final cost? So I'm going to find the percent of a number. So I'm going to take this tax rate and I'm going to turn it into a decimal, 0.0725, and I'm going to multiply it by the original price of her purchase. And that's going to give me 2.07, and it's money, so we'll round to the nearest hundredth. But then I need to take that $2.07 and I need to add it back to the $28.62 because she owes the amount of the tax and the amount of her purchase. And if I add that back to her original purchase, then Marnie needs to owe $30.69 as her final amount. Now, if we go to the store and there's a discount on something, but we also have to pay sales tax, then first is what we do is we find the discounted price, and then we find the sales tax on the discounted price. So we find the discount first and get that new price, and then we find the sales tax and add that on to the new price after the discount.